Two shafts here AB and BC of equal length and diameter equal to D and 2D are made of the same material. They are joined at point B through a shaft coupling while the end A and C are built in cantilevered. A twisting moment T is applied to the coupling, that is at this point, and if TA and TC represent the twisting moment at the end A and end C, then you have to find out the relation between TA and TC. So let's say we have a twisting moment at this section is equal to T, and let's say we have twisting moment at A will be in opposite direction, let's say equal to TA, and the twisting moment at C, that is the reaction torque at C, will be equal to TC. External torque acting is in the clockwise direction, that will take as a positive value, and the rest two will take as a negative value. Since here both the ends are fixed, basically this problem is a statically indeterminate problem, and we know that the value of angle of twist in the shaft 1 and shaft 2 are equal but opposite in direction. So let's say this one is shaft 1 and this one is shaft 2. At end A we have shown the reaction in downward direction, so we will mark here the value of TA in downward direction. You have to treat this value of TA as a negative value. In between A and B no torque is acting, so the torque is remain constant for the shaft 2. So in this case we have T2 will be equal to minus of TA. Then the torque is applied at the coupling. You have to purposefully show the addition of T2 and this torque T, so that will come on the positive side, and one angle of twist will be positive, other will be negative. So this one is the external torque applied at the coupling, and now the torque is remain constant from B to C. T1, and this value of T1 is the sum of the previous two value, that is this value is positive and this value is negative. So we have T1 equal to T minus TA, and then we have reaction torque at point C, so we'll end at C. So we have TC will be same as equal to T1. So we have TC, that is this value is TC, is same as equal to T1 is equal to T minus TA. One additional equation we can apply for statically indeterminate problem, that is a compatibility equation, which says that the theta 1, that is this value of theta 1 is positive and this value of theta 2 is negative, together of theta 1 plus theta 2 will be equal to 0. Theta 1 is given as T1 into L1 divided by J1 into G, plus we have T2 into L2 divided by J2 into G is equal to 0. Since he says that the material is same, it means that the value of G will be get cancelled, and we can replace here the value of T1 as T minus TA, and we can replace T2 as minus TA, and we can get a relation between T and TA. So let's cancel out this value of G on both sides. We can replace here T1 as T minus TA. So we have T minus TA multiplied by L1 is equal to L. J1 is pi by 32. So pi will adjust in denominator and 32 will shift in numerator. It's a d to the power 4, that is 2d to the power 4. Term G is get already cancelled, plus we have T2 which is equal to minus TA. So we have minus TA. L2 is L by 2. So we have L divided by 2. J2 is again pi and 32 will write in numerator. And we have D2 is equal to D. So we have D to the power 4 equal to 0. Number of terms will be get cancelled here, 32 pi, even L will be get cancelled, D to the power 4 is also get cancelled. So we have T minus TA. 2 to the power 4 is 16, and here we have minus of TA divided by 2. So we have minus TA divided by 2 equal to 0. So this 2 is again cancelled with 16. We left here with 8. We cross multiply and we'll solve this. So we get t minus ta. This 8 is multiplied is minus 8 times of ta equal to 0. So this one is total 9 times of ta. So we have 9 times of ta is equal to t, or we have ta, that is the reaction torque at the support A, will be equal to T divided by 9. But you have to find out the relation between TC and TA. Now we know here that TC is equal to T minus TA. So since here we have TC is equal to T minus TA, T will be as it is minus T by 9. T by 9 will be equal to 8 by 9 times T. So clearly here the value of TA is T by 9 and value of TC is 8T by 9. It means that we have value of TC will be 8 times the value of TA. We have TC is 8 times of TA. Choice B is correct. A step shaft is shown as below. The angle of the twist at B we have to find out when a torsional load of 4000 Newton meter, that is a 4 kilonewton meter, is applied at B. Again, this one is a problem of a statically indeterminate, so we can use the compatibility equation, that is the twist in the shaft 1 plus the twist in the shaft 2 must equal to 0. Out of that, the shaft 1 is a solid, shaft 2 is a hollow shaft. Value of G are given, both are different value, and length are also different. So first we'll draw here the torque diagram, then we'll find out here what is the torque acting on the shaft 1 and the shaft 2. Once we know the value of the torque T1 or T2, then we can calculate the value of theta using TL by JG, either by using the shaft 1 or either by using the shaft 2. The torque reaction at C and A, you have to always show opposite in direction of the externally applied torque of 4 kilonewton meter. So let's say this one is the direction which is opposite to this external torque, and let's say this value is equal to TC. Same direction will show here also. This one is the reaction at A, that is TA. Again, this value of TA will take it positive and this two value will take it as a negative value, that is TC and TA will take as a negative value. There is no sense in making the clockwise positive or anti-clockwise positive. Any one direction you can take positive, the opposite you have to take as a negative value. So this torque reaction is negative, so you have to show it downward. So this one is torque at point C, that is TC. One value you take it negative, other value must come back to be positive. So that theta 1 plus theta 2, one is positive, one is negative, total will be equal to 0. So this shaft which we are labeled as 2, the T2 value, so T2 will be same as equal to minus TC. At this point we have to show the torque 4 kilonewton meter, which one is a positive value, and somehow you have to come above the 0 reference level. That is the condition to draw the torque diagram in the case of statically indeterminate problems. So this torque is TB is equal to 4 kilonewton meter, that is 4000 Newton meter, and between A and B no external torque is acting, so this torque is remain constant. So this one is representing the torque T1. T1 value is the sum of the previous two value. So in this case we have T1 is equal to 4 kilonewton meter plus T2, which one is minus TC, and then you have to close the diagram. So this same value will represent here the value of TA. So we are ready here with T1 and T2. Both value of T1 and T2 we have find out with the help of TC. Find out the value of theta here using the T2 value. So we have a compatibility equation in the case of statically indeterminate problem is theta 1 plus theta 2 equal to 0. Theta 1 is same as T1 multiplied by L1 divided by J1 into G1 plus we have T2 into L2 divided by J2 into G2 is equal to 0. T1 we can replace as 4 minus TC. So if I write here this value is in kilonewton meter, then I can solve the problem and my answer of the torque will be kilonewton meter. So let's replace here T1 as 4 minus Tc multiplied by L1, which is 1.2 meter. So both sides will length in meter. So we have 1.2 meter divided by pi by 32. So 32 will shift in numerator. Diameter is 45. So we have 45 to the power 4. So diameter will take for both is equal to mm. So that is automatically get cancelled. G1 is equal to 28 gigapascal. So only will multiply by 28. Giga will on both sides will get cancelled. Plus we have T2 is equal to minus Tc. So we have minus Tc. Length L2 here we have taken in meter. So here also we'll take in meter is multiplied by 2 divided by pi. 32 will shift in numerator. D to the power 4. Now this time it's a hollow shaft. So we have outside diameter equal to 60 to the power 4. Inside diameter is 30 to the power 4. And the G value for shaft 2 is 84 gigapascal. So this is giga and this one is giga. So this will be get cancel on both sides. So right hand side will be equal to 0. Now 32 and pi will be get cancelled. Now to solve this it will take some time. We have 4 minus Tc and all this term will shift to the right will be equal to Tc into 2 and this term is cross multiplied is 45 to the power 4 into 28. This value of 1.2 will write in denominator and this value will continue 60 to the power 4 minus 30 to the power 4 multiplied by 84. So solve this constant first. So we get here 4 minus Tc equal to this whole constant is 0.1875 times Tc. So this Tc value will shift and we'll get here 1.1875 times Tc is equal to 4 kilonewton meter. So we have Tc is equal to 3.3684 and the unit of this quantity will be kilonewton meter. Now Tc is known, it means that the value of T2 is known. So magnitude wise we can find out here the angle of twist. So either theta 1 or theta 2 we can find out. So we'll try to find out the value of theta 2 here, which is equal to T2 into L2 divided by J into G2. So we have torque is equal to 3.3684. It's a kilonewton meter is 10 to the power 6. We have length, this time we have taken a standard unit equal to 1.2 meter is 1200. Then we have J is equal to pi by 32 will shift in numerator and we have D to the power 4. Now this time it's a hollow shaft, so we have 60 to the power 4 minus 30 to the power 4 and G2 value you have to take in megapascal, that will be 84. So it's a 84 into 10 to the power 3. So lot of calculations are involved in this case. So we have theta 1 is almost same as equal to theta 2. I will say the absolute value. So we'll get this answer close to 0.0673 radian, and we can convert it into degree. For this you have to multiply 0.6073 with 180 divided by pi. Your answer is very close to 3.86 degree. So the strategy in the case of statically indeterminate problem is that whatever the torque is applied externally in between the two fixed support, exactly opposite torque you have to show on the two end, such that one torque diagram will be above and one torque diagram will be below. So positive and negative will make it equal to 0. That is a comparative equation will be satisfied only when this torque diagram will be above the 0 reference level and this torque diagram will be below the 0 reference level. Then only you will get theta 1 plus theta 2 equal to 0. A step shaft PQR is fixed at both ends. So this one is again a problem of statically indeterminate problem. A torque T is applied at the point Q. The polar moment of inertia of the shaft PQ and QR are J1 and J2 respectively, and the modulus is same, that equal to G. The angle of twist at point Q due to the torque T is given in radian by which of the equation we have to find out. So again we'll consider here this one is shaft 1 and this one is shaft 2, and since it's a statically indeterminate problem, we have theta 1 plus theta 2 will be equal to 0. But before this we'll find out here what is the torque in the shaft 1 and shaft 2. So externally applied torque at point Q is shown in this direction, which one is basically anti-clockwise. So here we'll show this torque in a clockwise direction. Let's say this one is torque TR. Almost same direction we'll use here also. That is a fixed strategy for this type of problem. And this torque equal to TP. This value will take it positive and this two value will take it as a negative value. The quick formula don't apply when J1 and J2 they are not equal and length are not equal. So you have to construct the torque diagram. This value will take as a negative, so we'll show it downward. So let's move downward and let's represent this torque equal to TR. Then no torque is acting between Q and R, so torque is remain constant, and this value of the torque in the shaft 2 is T2, and you treat this value equal to minus of TR. Then at point Q you are applying a torque equal to T, so this will give you negative torque, so here you must get positive torque, and therefore you have to show the height of T so that you will come to the positive side of a torque diagram. So this one is torque T. So you must move from negative to positive. Then between P and Q no torque is acting, so torque is remain constant. So we'll draw here horizontal line representing the value of T1. And we know that this value of T1 is a sum of the previous two value, that is T minus TR. So we have T minus TR. And finally you have to close it by applying a torque at point P. So this value is TP. In this case the value of TP is same as equal to T1. Now the strategy is fixed here. We have complete equation is theta 1 plus theta 2 equal to 0. Theta 1 is T1 L1 by J1 G1 plus T2 L2 by J2 G2. G1 and G2 they are same value, that will be get cancelled. We have T1 is equal to T minus TR multiplied by length L1, that equal to 2 times of L. Or this value is directly given in the form of J1. So we have divided by J1 plus we have T2 is minus TR length L2 is same as equal to L, and again divided by J2 is equal to 0. So at this stage L will be get cancelled and this term will shift to the right. So on the left hand side we have T minus TR divided by J1. This value will become positive is TR by J2, and we are left here with 2. So that 2 will multiply in the numerator. So let's expand it and we have to solve this, and then we have to prove this equation. So J1 will multiply, 2 will divide, so we'll get T minus TR equal to J1 divided by 2 times of J2 multiplied by TR. So TR will shift, in that case we will get 1 plus J1 divided by 2 times of J2 multiplied by TR is equal to T. We'll take LCM equal to 2 times J2. So in numerator we have 2 times of J2 plus J1 is further multiplied by TR equal to T. So we know the torque T2 in terms of TR. So in this case we obtain the value of TR is equal to 2 times of J2 multiplied by torque T divided by 2 times of J2 plus J1. And using TR, that is the value of T2, that this value is same as equal to T2 value. Negative value doesn't matter. We'll calculate here theta 1, and theta 1 is the same as absolute value of theta 2, which is again equal to T2 L2 by J2 into G. Let's substitute for T2. T2 will be equal to 2 times of J2 into T divided by 2 times of J2 plus J1. So this one is substitution for T2, multiplied by L2 and divided by J2 and divided by further G. Now this value of J2 and this J2 is get cancelled, and we have L2 value is same as equal to L. So we replace here L2 is equal to L. So finally what we are getting? We are getting here 2 times of T multiplied by L, and whole thing is divided by 2 times of J2 plus J1 multiplied by G. Now check this equation. We have 2 times of TL. So here we are getting 2 times of TL. Here also we have 2 times of TL, but denominator is matched here. Is J1 plus 2 times of J2 and multiplied by G. So our choice D is correct choice. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.